Hello everyone, welcome to Excel Maths. Today we are starting the last topic of the same chapter, algebraic expressions, and this is Surds. We are very familiar with Surds right from GCSEs. Obviously you've done it in before, but here it's just an extension and maybe some complex questions we are going to discuss. So let me move to the next slide, and we are going to be having a concept understanding where we'll discuss about the surd first. So you know what exactly a surd is. If we have a radical symbol and any number, if it's written over there, it's a surd. But what not a surd is? So if I draw a radical and write a perfect square number there. So perfect square, 4 is a perfect square. That means even though it's inside the radical, but it's not a surd. If you have a fractional number, say for example 4 over 9 or 4 over maybe not 9, 19, it's a fraction, it's not a surd. If we have 2.32, it's not a surd. So meaning a perfect square under the radical, a fraction or a decimal number does not make a surd. Right? Hope it's clear. Now we'll talk about operations on surds. Operations, that means adding, subtracting, multiplying and dividing. So as surds is not really different than handling variables. Like if you know you can add x plus 2x, that gives us 3x. But if the question comes x plus 2y, we actually can't add it. It's a simplified form. The answer will be x plus 2y itself. Same for surds. If you have same surds or like surds, we gonna see that. So for example, if you have root 5 plus 2 root 5, that gives us 3 root 5, correct? But if you have root 5, say for example 2 root 5 plus 3 root 2, we can't solve it more. It is the final answer. Same goes for subtraction. So if I say x, 5x, take away 2x, it gives us 3x. But 5x, take away 2y, no, we can't. Correct? Similarly, if I say 5 root 2 minus a root 2, 5 root 2 minus root 2. So it's not any number, that means it's 1 there. So generally, because it's nothing visible there, so we also can't see what the number is, right? But it's 1 there. So 5 root 2 take away 1 root 2 gives us 4 root 2, correct? If I say it's 5 root 2 take away 2 root 3, we can't simplify that, correct? Now let's move to the next concept where we are going to be learning about multiplying and dividing fractions. So when we talk about multiplying and dividing, not fractions but surds. Okay, so if it's again the same goes like algebra, it's just not like indices are going to be adding what to say. Okay, let's see. So if I say it's root 2 times root 5, right? We draw a radical symbol there and write both the numbers under that. So root 2 times 5 is 10. This is how we multiply surds. If it comes to divide surds, say for example you have root 15 divided by root 5. So we're going to be drawing a big radical symbol. We will write 15 divided by 5 inside, and that will give us 15 divided by 5 gives us 3. So that is our answer. Hope that makes sense. After multiplying and dividing, we will be talking about simplifying surds. That's a nice, kind of a good concept. Simplifying surds. Right? We're going to be talking about, so for simplifying surds, I'll show you the square numbers here. So if I say 1 is a square number, right? 1 is the square number of 1. 4 is the square number of 2. Then 9 is the square number of 3. 16 is the square number of 4. 25 is the square number of 5. 36 is the square number of 6. 49, 7. 64, 8. 81, 9, and 100, 10. So if I say square root of 1 is going to be 1. Square root of 4 will be 2. Square root of 9 is 3. Square root of 16 is 25. Same goes for all. Correct? Okay. When we simplify surds, say for example, we have to simplify square root of 8. So what we do, we just try breaking it as a, we're going to be writing the factors of 8, but keeping the perfect square number closer to 8. So these inside numbers are perfect squares, no? This is a perfect square. They all are perfect square. So which number is the factor of 8? It is 4. 4 is the perfect square number. So what we're going to write, 8 can be written as 4 times 2. Now, what we did, we are just trying to breaking 8 as like writing factors. Out of all the factors, 1 should be the perfect square. We just try to write the perfect square. So square root, we can break it like this. Square root of 4 times square root of 2. Square root of 4 is nothing but 2. And root 2 would be root 2. So this is what the answer is. If that makes sense, you can directly come up, square root of 4 will give you 2, and that 2 would be inside, and this is what your answer is. If I give you square root of 18, okay, now you have to think, obviously 4, it's not the factor of 18. Next perfect square is 9. Yes, it is, 9 is the factor of 18, so we can write 9 times 2. So square root of 9 gives us 3, and root to be written as it is. So 3 root 2 is the answer. If I say square root of 75, yeah, now you need to think which perfect square is the factor of this number. Yes, 25, we can write 25 times 3. So 25 gives us 5 and root 3. This is what the answer is. So this is how we simplify surds, correct? Based on what we learned, let's go through some questions. So the first question comes square root of 12. So for 12, if we see 4, yes, 4 is the perfect square. That is the factor of 12 as well. 4 times 3. 4 could be written as 2, so the answer goes to root 3. 20, again, smaller than 20 and the factor of 20. So that is nothing but 4. So we can say 4 times 5 is 20 over 2. So square root of 4 will give us 2. So we can write 2 root 5 over 2. We can cancel them. So the answer goes root 5. Correct? It's a good question. C part. Root 6 is basically 5. Root 6 has two factors, 3 and 2, and none of them is a perfect square. So we're going to be keeping root 6 written there. Minus 2. 24, just think of the perfect square. That is the factor of 24. Yes, 4 again. Can we write it as 4 times 6 plus 294. So 294 is a big number. We have to think of what the factor of 294 could be, right? So because 249 is a big number, I'm not very sure of what the factors are. So I'm going to be prime factorizing using the tabular method or the ladder method. So 294, we can divide by 2. That will give us 2 times 1, 2 times 4, 2 times 7. 147 is divisible by 3. 3 times 4 is 12 and 3 times 9 is 27. 7 and 7. So can we write it to be square root of 249? Can we write it as 49 times 6, right? This is what 49 is, perfect square. And even we could stop there also, no? We got a perfect square number. So the moment we are getting the perfect square, we have to stop. So 49 times 6. So it will be 5 root 6. Take away. This 2 comes out, multiplies with that 1. So gives us 4 root 6. 7 comes out, gives us 7 root 6. Okay, can we simplify this? 5 root 6 take away 4 root 6 gives us 1 root 6 plus 7 root 6 gives us 8 root 6. Hope that makes sense. So this is all about simplifying. Okay, expanding. So what exactly expanding is, as we did, in the previous third lesson, I guess, expanding is going to be, it will follow the same method. It's just surds here. So we will multiply root 2 with 5. So that will give us 5 root 2 minus root 2 times root 3. That gives us, we know what is root 2 times root 3, no? We just learned. So it would be 6. Correct. And this is what our answer is. When we have double brackets, let's expand. So what we do, we take the first term and multiply with the bracket 2 with 5 plus root 3. Then minus root 3, 5 plus root 3. Okay, now let's single bracket. It's easy. So 2 times 5 is 10 plus 2 times root 3 gives us 2 root 3 minus root 3 times 5 gives us minus 5 root 3 minus root 3 times root 3 gives us root 3 times root 3 is nothing but root 9. That gives us 3. So just remember, we can keep it as a concept. Whenever a same surd multiplies, we get it surd free. Right? Root a times root a gives us a. Root b times root b gives us b. Root 7 times root 7 gives us 7. Root 3 times root 3 gives us 3. So, following the same, we're going to be getting minus 3. Correct? Okay. So, 10 minus 2 root 3 minus 5 root 3. It will give us minus 3 root 3 minus 3. So, these two are whole numbers or integers. We can solve them together. That will give us 7 minus 3 root 3. This is how we expand. So there is nothing new. It's just, follow the same method and keep going. Next we have simplifying, and let's go with that. Root 75 we just did during discussion. It was 5 root 3, no? So we're going to be writing 5 root 3 minus root 12 was 4 times 3. So 2 root 3. That will give us 3 root 3. So what the value of a is 3. Correct? Easy peasy. Now we'll talk about rationalizing denominator. So, okay, I don't have any space, so I'm gonna explain it there. So for rationalizing denominators, you either are going to be getting only one monomial. Monomial meaning one term down there at the bottom, meaning denominator will have only one surd. It wouldn't be an expression, nothing. It would be a one simple surd. So what we need to do that, we just multiply and divide by the surd. Correct? Because we know root 3 times root 3 makes 3. We just have to make the denominator. Rationalizing means what? Making the denominator surd free. So it would be 1 times root 3 over root 3 times root 3. It will give us root 3 over 3, and that is our answer. When you have an expression there, what we do? We just if it's 3 plus root 3, we are going to be multiplying and dividing by, if it's positive, it's a sum, so we're going to be multiplying by the difference. We just multiply by the opposite operation. So it was 3 plus root 2, we have multiplied by 3 minus root 2. Say for example, if it is 2 over root 3 minus root 5, what are we going to be doing? Yes, root 3 plus root 5 and root 3, whatever we multiply, we're going to be dividing by that. So the top and bottom is going to be same, and it will be opposite to what the operation we have over here. Okay, nice. Now let's simplify. So it would be 1 times that will give us 3 minus root 2, and at the bottom we will be getting 3 plus root 2 and 3 minus root 2. If you're following all the lessons, you are going to be getting no new thing added over here, because I already have explained all the things before. So this is when you have same terms with plus and minus, that means it is nothing but the difference of squares. I'll be writing it quickly over there. So what is difference of squares? If you have a bracket A, say for example, two numbers A and B, first with a plus and the other one is minus, so we can write it as difference of squares, taking the numbers and writing the difference of the squares. So the top is going to be 3 minus root 2 and the bottom is 3 squared minus root 2 squared. Okay, again root 2 squared. Root 2 squared is nothing but root 2 times root 2, and we know that is 2. Correct? So it will give us 3 minus root 2 over 9 minus 2. That's 3 minus root 2 over 7. Hope that makes sense. Now for this case, what we need to multiply? We need to multiply by root 5 plus root 2 over root 5 plus root 2. So the denominator is going to be 5 minus 2, that is 3, and the top would be just expanding. I'm writing, I won't solve it completely. So the top is actually asking us to expand root 5 plus root 2 and root 5 plus root 2. So squaring that, and the bottom is going to be 5 minus 2. How 5 minus 2? Root 5 minus root 2, the other bracket root 5 plus root 2. So what we discussed, that it is nothing but the square difference of squares. What the numbers are? Numbers are root 5 and root 2. So root 5 square is going to be giving us 5 minus square of square root 2 will give us 2. So that gives us 3. Right, you can expand. So overall finally you're going to be getting 5 plus 2 plus 2. Root 5 times root 2 will be root 10 over 3. So anyway, we can say 7 plus 2 root 10 over 3. This is your answer. D part is interesting. Let's try that. So for the D part, it is 1 over 1 minus square root 3 whole squared. So I feel like we have to solve, expand this first. So 1 over 1 squared plus square root of 3 squared minus 2 times 1 times square root 3. This is what we discussed in expanding brackets. So you can refer that lesson. It was third lesson. 1 over 1 plus square root of 3 squared is 3 minus 2 root 3. So that is simplified as 1 over 4 minus 2 root 3. Correct? Okay. Now we have some questions from practice book. So these are bronze, silver and gold questions. So let's go through one by one. We have to simplify this. 147, I think we saw it somewhere. It was 3 times 49, if I'm not wrong. We did it. 100%. Yeah, 147 is here, if you can see. So 147 is 3 times. Oh, no worries, you need not to learn these things. So we are going to be using tabular method. 147. So is divisible by 3. How? If you add the digits, 3 plus 1 is, 4 plus 1 is 5. 5 plus 7 is 12. So 12 is divisible by 3. Let's divide by 3. 3 times 4 is 12. 13, 14. 3 times 9 is 27. So we can write it to be square root of 3 times 49 minus square root of 75 can be written as 3 times 25. Okay. So 49 will give us 7 and 25 will give us 5 outside. So we can write 7 root 3 minus 5 root 3. So that comes up to be root 3. 2 root 3. So our A is 2 here. It was easy, no? Okay, the next question, look a bit, okay, so the top part we have to use. So hence that means we have to, take things from the A part. So you have 24 root 2 over the top thing. Top thing simplifies to be 2 root 3, no? Okay. So we can simplify this, that would be 12. So we can write 12 root 2 over root 3. Because we didn't get the same form, we want root 6. So let's rationalize root 3 over root 3. That will give us 12 root 6 over 3. So 3 times 1, 3 times 4, that gives us 4 root 6. So what the value of B is nothing but 4. Correct? Yeah. Now let's move to the next question. Expand and simplify. Easy peasy. So expanding and simplifying. So let's do, it's like not difficult really. It's just letting you practice. So we will multiply 11 to whole bracket. So 11 times root 5 plus 1. Then plus root 5 with a bracket root 5 plus 1. Correct? Let's multiply 11 times root 5 will give us 11 root 5 plus 11 times 1 will give us 11 plus root 5 times root 5 gives us 5. No need to explain. Root 5 plus 1 is, root 5 times 1 is root 5. Okay, these two can simplify together and these two together as well. 11 root 5 plus root 5 meaning plus 1 root 5. So it will be 12 root 5 and 11 plus 5 is 16 and this is our final answer. They want A, so A, this is A and that's B. They want in the form, so you can write, okay, 16 plus 12 root 5, right? This is your final answer. Hence, okay, we have to use the top thing. Hence, otherwise simplify this. So this is nothing but, okay, 11 plus root 5 over root 5 minus 1. This is the B part we are solving. Okay, so I think we have to rationalize because it has no denominator, no? So let's rationalize. So it would be root 5 plus 1, perfect, over the same thing, root 5 plus 1. So the top we're going to be getting to be 11 plus root 5 and root 5 plus 1 over what that would be difference of square. So it would be root 5 squared, that is 5, and 1 squared, that is 1. So the top thing we already simplified, that was 16 plus 12 root 5 over 4. Can we take the 4 common from the top? So if we take 4 common, it would be 4 plus 3 root 5 and down there we have 4. That can be cancelled. So we get the final answer to be 4 plus 3 root 5. Where, okay, so 4 is basically C and 3 is D. Right, so we are done with our silver level also. Let's move to the gold. Okay, it's again very, very, very easy. So let's try. It's just rationalizing, no? 6 root 3 minus 4 over 5 minus root 3. What the step is? Yes, to multiply and divide by the same expression which is showing opposite to what it is. It's minus, so it would be plus. 5 plus root 3. Okay, nice. So the top is going to be expansion, which makes the question lengthy. Otherwise, they are very easy. The bottom, you can see the difference of squares. I mean, whenever you rationalize, the difference of square is the backbone of rationalizing. So you will be getting 5 squared minus root 3 squared. Okay, it would give you nothing changing, but the bottom let me write 6 root 3 minus 4 and 5 plus root 3 over 25 minus 3 is 22. Correct? Now the top is like expanding, so let's expand 6 root 3 with the bracket, which is 5 plus root 3, minus 4 with the bracket, which is 5 plus root 3, and the denominator is waiting down there. Okay, so 6 root 3 times 5 will give us 30 root 3 plus 6 root 3 times root 3 will give us, root 3 times root 3 is 3, 6 times 3 is 18. Okay, minus 4 times 5 is a negative 20, and minus 4 times root 3 is a negative 4 root 3 over 22. Okay, we can simplify these two. 30 root 3 minus 4 root 3, that gives us 26 root 3. 18 minus 20 gives us 2. A negative 2, I mean. A negative 2. 18 minus 20 is minus 2 over 22. Okay, now because we have to write in this form where P and Q are positive rational numbers. Okay, so can we write it as 26 over 22 root 3 minus 2 over 22? We can simplify. That will give us 13 if you divide by 2. 13 over 11 root 3 minus 1 over 11. Correct? So I think P is 13 over 11 and Q is 1 over 11. 13 over 11 and 1 over 11. This is what the P and Q is, and they are positive rational numbers. Yes, they are. This minus is actually present there as well, no? Okay. Hope this makes sense and helps us get 4 marks. Now we are going to be solving questions. I mean, this question we already did, if you could remember. We did it earlier. So we are missing this. This one we didn't discuss yesterday. So today we are going to be solving it. We have to solve the equation. So whenever you have, degree 4 or the highest power 4, what we do, we take b squared as, say for example, x. So wherever you have b squared, b to the power 4, can we write it as b squared whole squared plus 7 b squared minus 18? You would be able to relate. Yesterday we discussed many questions like this, in the previous lesson. So b squared is going to be replaced by x. So we have b squared here and here. So let's write x squared plus 7x minus 18 equals 0. Or multiplies to give you 18 and adds to give you 7. 9 times 2 and 9 times minus 2 basically. So it would be x 9 times minus 2, right? Plus 9 and x minus 2. That is equal to 0. But it was not x. The equation was in terms of b. So let's go back to b squared. So we're going to be, just give me a sec. we're going to be turning x into b squared again. So this would be b squared plus 9, and here it will be b squared minus 2. That is equal to 0. Correct? Now b squared plus 9 and b squared minus 2. So from here, if you have to find out the values, it would be giving us b squared is equal to minus 9, which is not going to be a real solution. So we're going to be writing b squared is equal to minus 2 equals 0. So b squared is equal to 2. So from here we will get b to be positive negative root 2. Correct? Okay. So our final answer goes for the real solutions to the equation. So we're going to be getting b to be a positive root 2 and a negative root 2. Next we have this one. We already discussed. Today we have to discuss this question. So let's get started. Okay. So if I say let's move x there, so we can write x root 2 minus x and move 18 here. Square root of 18 we discussed. 9 times 2 is 18. Let me quickly do it here. 9 times 2 is 18. 9 will be giving us 3. So 3 root 2. We can write it like this, right? So it would be 3 root 2. And you can take x common. So it would be root 2 minus 1. What do they want? They want the value of x. Okay. So x is going to be 3 root 2 over root 2 minus 1. But this is not the solution. They want the surd in simplest form. That means we have to rationalize. So let's rationalize. What we do? Root 2 plus 1 and root 2 plus 1. It's easy and quick also. So we're going to be writing 3. I'm writing here 3 root 2 with a bracket root 2 plus 1, and down there we will be having difference of squares. So square root of 2 squared is going to be giving us 2 minus 1. If we expand the top thing, it would be 3 root 2 times root 2 will give us 6. Hope that makes sense. 3 root 2 times root 2. So root 2 times root 2 is 2. Times 3 gives us 6. And 3 root 2 plus times 1 is 3 root 2 over 1. So yes, the final answer comes 6 plus root 3 root 2. Okay. Oh, it's not the class break. It is the chapter break. Yay, yay, yay. But it's not the chapter break. I will be including one more quick lesson where we are going to be discussing some more questions which are, from the same practice book we have, having the category bronze, silver, gold. And after that, we would be done with the lesson. Okay, thank you so much. Bye-bye. Keep learning and growing. Bye-bye. Take care.